What is 5G, and how does it differ from previous generations? 3, 2, 1, 0. 5G is the fifth generation of mobile networks, offering enhanced speed, lower latency, and greater capacity. Unlike 4G, it uses higher frequency bands, enabling faster data rates and supporting a larger number of devices. Explain the role of mmWave technology in 5G. 3, 2, 1, 0. Millimeter wave. mmWave technology provides high-speed data by using higher frequencies, 24 GHz and above. It allows greater data rates and low latency, essential for applications like AR, VR, but has limited range and penetration capabilities. What are the key components of a 5G architecture? Key components include the Radio Access Network, RAN, Core Network, and Edge Computing. RAN connects devices to the network. The Core manages traffic and data, and Edge Computing processes data closer to users for faster response times. What is network slicing in 5G? Network slicing is a method that divides a single physical 5G network into multiple virtual networks, tailored for specific use cases like IoT, mobile broadband, and low-latency applications. How does 5G impact IoT and smart cities? 5G supports IoT by connecting millions of devices in real time, improving applications in smart cities like traffic management, utility monitoring, and emergency response systems. Describe the 5G New Radio Air interface. 3, 2, 1, 0. 5G Near is designed to support various spectrum bands and offers advanced features like beamforming, massive MIMO, and flexible numerology, which help enhance data rates and network efficiency. What is beamforming, and why is it important in 5G? Beamforming is a signal processing technique that directs data signals to devices, improving speed and reliability. In 5G, it helps overcome mmWave limitations by focusing signals on user locations. What is MEC, multi-access edge computing, in 5G? MEC enables data processing at the edge of the network rather than in a central cloud, reducing latency and allowing applications like autonomous driving and VR to operate more effectively. Explain the differences between SA, standalone, and NSA, non-standalone, 5G deployments. NSA relies on 4G LTE infrastructure and is faster to deploy but with limited 5G capabilities. SA 5G operates independently, providing full 5G benefits, including low latency and improved speed. What is massive MIMO, and how does it enhance 5G performance? Massive MIMO MIMO uses multiple antennas at the base station to handle multiple data streams, improving capacity, data rates, and coverage, essential for dense urban areas. What are the security challenges in 5G networks? 3, 2, 1, 0. 5G faces security challenges like increased attack surfaces due to IoT and higher data rates, making encryption, authentication, and network segmentation essential. And describe the role of AI in 5G networks. 3, 2, 1, 0. AI optimizes 5G network management by enabling predictive maintenance, optimizing resource allocation, and improving user experience through data-driven insights. What are the main frequency bands used in 5G? 3, 2, 1, 0. 5G operates in three main bands: low band, less than 1 GHz, mid band, 1 to 6 GHz, and high band, 24 GHz plus. Each has different coverage and speed characteristics. How does 5G improve latency over previous generations? 3, 2, 1, 0. 5G reduces latency to 1 millisecond or lower through edge computing and faster radio access technologies, enabling real-time applications like gaming and remote surgery. Explain the concept of URLLC in 5G. 3, 2, 1, 0. Ultra-reliable low-latency communications. URLLC supports mission-critical applications, like autonomous vehicles, by prioritizing reliability and reducing latency. How do small cells contribute to 5G networks? 3, 2, 1, 0. Small cells enhance network coverage and capacity in high-density areas by shortening the distance between users and base stations, vital for mmWave in urban environments. What is DSS, dynamic spectrum sharing, in 5G? 3, 2, 1, 0. DSS enables 4G and 5G to share the same spectrum dynamically, allowing operators to transition between technologies without additional spectrum allocations. How is virtualization applied in 5G networks? 3, 2, 1, 0. 5G uses network function virtualization, NFV, to run network functions on software rather than hardware, enabling scalability, flexibility, and cost savings. What is the role of the 5G core network? 3, 2, 1, 0. The 5G core supports higher data rates, flexible network slicing, and improved connectivity management compared to 4G. Designed to handle the demands of IoT and edge computing. What role does OFDM, orthogonal frequency division multiplexing, play in 5G? 3, 2, 1, 0. OFDM is the primary modulation scheme in 5G, enabling efficient data transmission across multiple frequencies and enhancing spectral efficiency, which supports higher data rates and robustness against interference. How does carrier aggregation, CA, Enhance 5G performance. 3, 2, 1, 0. CA combines multiple frequency bands to increase data rates and improve network efficiency, enabling faster connections and higher throughput, especially in congested areas. What is the significance of flexible numerology in 5G? 3, 2, 1, 0. Flexible numerology allows 5G networks to adapt the subcarrier spacing and slot duration based on specific use cases, enabling optimized performance for varied applications like URLLC and enhanced mobile broadband (EMBB). How does 5G handle interference management? 3, 2, 1, 0. 5G uses techniques like coordinated multipoint (COMP) and inter-cell interference coordination (ICIC), which enable nearby base stations to manage and reduce interference, especially in high-density environments. Explain how the 5G architecture supports private networks. 3, 2, 1, 0. 5G's modular architecture, network slicing, and secure core components allow enterprises to set up private networks tailored for specific needs, ensuring dedicated resources, enhanced security, and optimized performance. What is the impact of 5G on cloud-native architecture? 5G Core is built on cloud-native principles like containerization and microservices, enabling scalable and efficient deployment of network functions in virtualized environments. Describe the significance of dual connectivity in 5G networks. 3, 2, 1, 0. Dual connectivity enables devices to connect to both LTE and 5G networks simultaneously, improving reliability, coverage, and data rates during the initial 5G deployment phases. What role does IPv6 play in 5G networks? 3, 2, 1, 0. 5G networks utilize IPv6 to manage the vast number of devices, especially IoT, by providing a virtually unlimited IP address space, enhancing network scalability and security. How does 5G optimize energy efficiency compared to previous generations? 3, 2, 1, 0. 5G implements energy-saving techniques like sleep mode for idle cells, efficient scheduling, and advanced antenna technologies like massive MIMO to lower overall network power consumption. What is eCPRI and its role in 5G? 3, 2, 1, 0. Enhanced Common Public Radio Interface (eCPRI) is used in 5G networks for efficient and scalable communication between the RAN and core, improving data throughput and reducing latency. Explain the function of the user plane and control plane in 5G. 3, 2, 1, 0. The user plane handles data traffic, while the control plane manages signaling and network control functions. In 5G, these are split to optimize data routing and latency. How is latency managed in mission-critical 5G applications? 3, 2, 1, 0. 5G utilizes edge computing, network slicing, and optimized data routing to reduce latency, ensuring real-time performance for applications like autonomous driving and remote surgery. What is RAN virtualization, and why is it important for 5G? 3, 2, 1, 0. RAN virtualization, or VRAN, separates hardware from software, allowing operators to deploy radio resources more flexibly and efficiently, lowering costs and supporting scalable deployments. Describe the role of self-optimizing networks, SUN, in 5G. SUN automates network optimization tasks such as load balancing and interference reduction, improving network performance and minimizing manual intervention. How is quantum security relevant to 5G? 3, 2, 1, 0. Quantum security methods, like quantum key distribution, are explored to secure 5G data transmission against quantum computing threats, which could compromise current encryption. What are the key costs, quality of service, metrics for 5G? 3, 2, 1, 0. Key cost metrics include latency, throughput, reliability, and jitter. 5G's cost model can prioritize different applications based on their specific needs, essential for varied use cases. How does SDN, software-defined networking, complement 5G? 3, 2, 1, 0. SDN enables centralized management of network resources, increasing 5G's flexibility by allowing dynamic traffic routing and efficient resource allocation. What are the typical challenges faced in mmWave deployment? 3, 2, 1, 0. Challenges include limited range, high susceptibility to obstructions like buildings, and signal degradation in adverse weather, requiring more dense base station placement. How does network densification support 5G? 3, 2, 1, 0. Network densification involves deploying more small cells and base stations to increase network capacity and coverage, essential for high-demand areas and mmWave utilization. Explain the concept of mobile edge computing, MEC, use cases in 5G. 3, 2, 1, 0. MEC supports low-latency applications like smart manufacturing, connected healthcare, and real-time analytics by processing data at the network edge, close to end users. What is the significance of FWA, fixed wireless access, in 5G? 3, 2, 1, 0. Fixed wireless access uses 5G to provide high-speed broadband to fixed locations, bridging connectivity gaps in rural and underserved areas. It offers an alternative to fiber with quicker deployment and lower costs. Describe the concept of handover in 5G and its importance. 3, 2, 1, 0. Handover refers to transferring an active call or data session from one cell or frequency to another to maintain connectivity. In 5G, seamless handovers are crucial for low-latency applications and high-speed mobility scenarios. What is the purpose of mobile backhaul in a 5G network? 3, 2, 1, 0. Mobile backhaul connects the radio access network (RAN) to the core network, crucial for data transport across 5G networks, ensuring reliability, speed, and low latency. Explain the concept of RACH, Random Access Channel, in 5G. 3, 2, 1, 0. RACH is a channel that allows a device to initiate communication with the network. In 5G, RACH optimizations ensure efficient connection setups, especially critical in dense networks. What is 5G near carrier aggregation, and why is it used? 3, 2, 1, 0. 5G near carrier aggregation combines different 5G carriers across frequency bands to increase data throughput and improve overall network performance. It is essential for achieving peak speeds in 5G. How does network slicing support private 5G networks? 3, 2, 1, 0. Network slicing enables the creation of isolated, customizable virtual networks within a single 5G infrastructure, allowing dedicated resources for enterprise applications while ensuring security and efficiency. What are fronthaul and backhaul, and how do they differ in 5G? 3, 2, 1, 0. Fronthaul connects the radio unit, RU, and distributed unit, DU, while backhaul links the DU with the core network. Fronthaul is critical for low-latency connections in 5G, especially with C-RAN architectures. How does 5G enable enhanced mobile broadband, EMBB? 3, 2, 1, 0. EMBB provides high-speed internet for data-heavy applications like HD streaming, VR, and gaming. 5G achieves this with broader bandwidths and high-frequency bands, enhancing data rates significantly. Describe latency-sensitive applications enabled by 5G. 3, 2, 1, 0. Applications like autonomous driving, augmented reality, AR, and remote surgery rely on 5G's ultra-low latency, which ensures real-time responsiveness and reliability. What are the different 5G deployment modes? 3, 2, 1, 0. Deployment modes include standalone, SA, non-standalone, NSA, and hybrid. NSA uses 4G LTE for control with a 5G RAN, while SA uses an end-to-end 5G infrastructure. Hybrid combines both for phased implementations. How does Network Function Virtualization, NFV, benefit 5G networks? NFV allows for the virtualization of network functions, reducing reliance on dedicated hardware, enabling faster deployments, and allowing for scalable, cost-effective, and flexible network management. What is the purpose of control and user plane separation (CUPS) in 5G? 3, 2, 1, 0. CUPS allows for independent scaling of control and user planes, enabling efficient network management and resource allocation, which is crucial for data-intensive 5G applications. Explain the difference between beam steering and beamforming. 3, 2, 1, 0. Beamforming directs signals toward specific users, while beam steering dynamically changes the direction of beams to follow users as they move. Essential for consistent connectivity in 5G. What is network densification, and why is it essential for 5G? 3, 2, 1, 0. Network densification involves adding more small cells and base stations to boost capacity and coverage, especially important in areas with high data demands and for higher frequency wave. How does 5G support V2X, vehicle-to-everything, communication? 3, 2, 1, 0. 5G's low latency and high reliability make it suitable for V2X applications, enabling connected vehicles to communicate with infrastructure, other vehicles, and pedestrians for safer and smarter transport. What is the 5G Policy Control Function, PCF? 3, 2, 1, 0. PCF manages policies within the 5G network, controlling aspects like data prioritization, user authentication, and network access, ensuring efficient resource usage and adherence to service levels. How does 5G handle emergency services and priority traffic? 3, 2, 1, 0. 5G networks prioritize emergency traffic through dedicated resources and network slicing, ensuring reliable communication channels for first responders and critical infrastructure. What role does carrier bandwidth play in 5G performance? 3, 2, 1, 0. Carrier bandwidth determines the capacity of a 5G network. Wider bandwidths enable higher data rates, with typical 5G bands allowing from 10 MHz up to 100 MHz or more, depending on regulations. What is the difference between FDD and TDD in 5G? 3, 2, 1, 0. Frequency division duplex. FDD uses separate frequencies for upload and download, while time division duplex, TDD, alternates upload and download times on the same frequency, ideal for varying data loads. How does 5G address spectrum efficiency challenges? 3, 2, 1, 0. 5G employs advanced modulation, massive MIMO, and dynamic spectrum sharing to maximize spectrum usage, ensuring high throughput even in limited or shared frequency bands. What is massive MIMO, and why is it critical for 5G? 3, 2, 1, 0. Massive MIMO, multiple input, multiple output, involves using a large number of antennas to increase capacity and spectral efficiency, enhancing throughput and coverage. especially in dense urban areas. How does 5G enable ultra-reliable low-latency communications, URLLC? 5G achieves URLLC through features like optimized subcarrier spacing, efficient scheduling, and edge computing, ensuring minimal delays for critical applications. What is the purpose of dual connectivity in 5G? Dual connectivity allows devices to connect to both LTE and 5G networks simultaneously, enhancing reliability and enabling faster data speeds, particularly in NSA deployments. Explain the concept of uplink and downlink decoupling in 5G. 3, 2, 1, 0. Uplink, downlink decoupling enables different technologies for upload and download, enhancing performance in areas with limited coverage, especially for the uplink in challenging environments. What is edge computing, and why is it essential for 5G applications? Edge computing processes data closer to the end user, reducing latency and bandwidth usage, making it ideal for time-sensitive applications like VR and IoT in 5G networks. How does 5G support IoT applications more effectively than previous generations? 5G provides low power, low latency, and high device density support, making it ideal for IoT. Features like NB-IoT and massive machine-type communications, MMTC, are specifically designed for IoT needs. Explain the concept of time-sensitive networking, TSN, in 5G. 3, 2, 1, 0. TSN in 5G is used to ensure predictable data transfer with minimal delay and jitter, crucial for real-time industrial applications like robotics and automation. How does 5G handle frequency refarming? Frequency refarming allows older 3G, 4G frequencies to be reassigned for 5G, maximizing spectrum efficiency and enabling a gradual transition to full 5G networks. What is the purpose of the AMF, Access and Mobility Management function, in 5G? The AMF is responsible for managing registration, connection, and mobility aspects in the 5G core network, allowing seamless user movement and connectivity management. What role does SUN, self-organizing networks, play in 5G? SUN automates network operations, such as load balancing, interference management, and optimization, which enhances 5G's performance and reduces operational costs. How does dynamic spectrum sharing, DSS, work in 5G? DSS allows 4G and 5G to share the same spectrum dynamically, enabling operators to roll out 5G without requiring additional spectrum, especially in NSA setups. What is MEC, multi-access edge computing? in the context of 5G. 3, 2, 1, 0. MEC is a key component of 5G that enables cloud computing capabilities and an IT service environment at the edge of the network, reducing latency and improving application performance. Describe 5G's multi-layer security model. 3, 2, 1, 0. 5G security includes device authentication, data encryption, and network access control at multiple layers, enhancing protection against cyber threats, especially for critical infrastructure. What is the function of the SMF, Session Management Function, in 5G? 3, 2, 1, 0. SMF manages sessions and IP address allocation, controlling and routing data for specific user sessions to ensure efficient data management and quality of service. How does the 5G system manage network congestion? 3, 2, 1, 0. 5G manages congestion through cost control, network slicing, and prioritization mechanisms, ensuring critical applications maintain performance even during heavy usage. What are the primary benefits of beamforming in 5G? 3, 2, 1, 0. Beamforming focuses signal strength towards specific users rather than broad broadcasts, enhancing data speed, reliability, and spectral efficiency in dense urban areas. Explain the impact of 5G on AR and VR applications. 3, 2, 1, 0. 5G's low latency and high-speed capabilities enable smoother and more immersive AR and VR experiences, essential for applications in gaming, remote assistance, and training. What is control plane and user plane separation, CUPS, and its importance in 5G? 3, 2, 1, 0. CUPS enables independent scaling and management of data and control traffic, providing efficient resource use and enhanced network flexibility. How does 5G handle ultra-dense network environments? 5G uses techniques like massive MIMO, network slicing, and densification with small cells to manage capacity and maintain quality in crowded settings. What is the role of non-terrestrial networks, NTN, in 5G? NTNs involve using satellites and high-altitude platforms to extend 5G coverage to remote areas, filling gaps that terrestrial networks can't reach. What are the three main frequency bands in 5G, and what are their applications? 3, 2, 1, 0. 5G operates in low band, below 1 GHz, for broad coverage, mid-band, 1 to 6 GHz, for a balance of coverage and speed, and high-band, wave, above 24 GHz, for ultra-high speeds in dense areas. Each has specific use cases, with low band for rural areas, mid-band for urban, suburban, and wave for city centers. How does 5G enable precision agriculture? 3, 2, 1, 5G's high device density and low latency support IoT in agriculture, enabling real-time monitoring of crops, livestock, and soil, as well as automated machinery, which increases efficiency and crop yields. What is 5G non-public network, NPN, and its use case? Non-public networks, NPNs, are private 5G networks designed for specific enterprises or institutions, offering secure, high-performance networks for use in manufacturing, healthcare, and logistics without reliance on public networks. Explain network slicing isolation in 5G and its importance. 3, 2, 1, 0. Network slicing isolation ensures each slice operates independently, preventing interference and ensuring security. This is critical for enterprises using dedicated slices for sensitive or high-priority applications. What is the purpose of ORAN in the context of 5G? 3, 2, 1, 0. ORAN, Open Radio Access Network, standardizes open interfaces and virtualizes RAN components, promoting interoperability and vendor flexibility, which reduces costs and enhances 5G deployment options. How does service-based architecture, SBA, benefit 5G core? 3, 2, 1, 0. SBA uses modular network functions, each providing specific services accessible through open APIs, enabling scalability, flexibility, and easy integration of new functions, essential for 5G's diverse applications. What is the role of the user plane function, UPF, in 5G? The UPF handles data packet forwarding and routing between the user device and the Internet, enabling low latency, high-speed data transfer essential for 5G applications. Explain carrier aggregation and its advantages in 5G. Carrier aggregation in 5G combines multiple frequency bands to boost data speeds, providing higher throughput and better user experience, especially for high-band applications. What is the purpose of the access stratum, as, in 5G? The access stratum manages communication between the user equipment, UE, and the RAN, handling aspects like radio resource control, connection setup, and mobility, critical for device connectivity. How does 5G support healthcare applications such as remote surgery? 5G's low-latency URLLC allows real-time communication between surgeons and remote robotic equipment, supporting precise and reliable remote surgeries with minimal delays. What are the main protocols used in 5G signaling? 5G signaling uses protocols such as NGAP, Next Generation Application Protocol, for core-to-RAN communication, NAS, Non-Access Stratum, for control signaling, and SCTP, Stream Control Transmission Protocol. For transport, what is the role of data network, DN, in 5G? 3, 2, 1, 0. The DN in 5G connects users to external data networks, including the Internet and enterprise networks, providing access to a variety of services and applications. How does 5G enhance industrial automation? 3, 2, 1, 0. 5G's high reliability, low latency, and massive IoT support enable real-time monitoring, control of robotic equipment, and coordination in manufacturing plants, increasing productivity and safety. Explain the purpose of cost, quality of service, in 5G. 3, 2, 1, 0. Costs in 5G allocates resources based on priority, ensuring essential applications like emergency communications or VR have the required bandwidth, latency, and reliability. What is Distributed Antenna System, DAS, and how is it used in 5G? 3, 2, 1, 0. DAS involves multiple antennas distributing cellular signals to improve coverage in high-density areas, such as stadiums or campuses, essential for 5G high-capacity demands. How does network slicing support autonomous vehicles? 3, 2, 1, 0. Network slicing provides dedicated, secure, and low-latency slices for vehicle communications, enabling real-time data processing essential for autonomous driving safety. Explain the significance of D2D, device-to-device, communication in 5G. 3, 2, 1, 0. D2D allows direct communication between devices, reducing network load, latency, and power consumption, making it valuable for emergency communication and IoT applications in 5G. How does 5G handle dense urban environments? 3, 2, 1, 0. 5G addresses dense urban environments with techniques like small cells, wave frequencies, and beamforming to increase capacity and coverage in areas with high user density. What is self-optimizing networks, SUN, and its role in 5G? 3, 2, 1, 0. SON in 5G automates network optimization, including load balancing and interference management, which improves efficiency and network quality. How does 5G support mixed reality, MR, applications? 3, 2, 1, 0. 5G's high speed and low latency allow MR applications to process large amounts of data in real time, supporting immersive experiences for gaming, training, and remote assistance. How does 5G use network function virtualization, NFV? 3, 2, 1, 0. NFV virtualizes network functions, allowing them to run on common hardware instead of proprietary systems, enhancing 5G's scalability and reducing costs. It also enables fast deployment and dynamic scaling of network services. What are Integrated Access and Backhaul, IAB? nodes in 5G, and why are they important? IAB nodes are 5G components that provide both access and backhaul connectivity, reducing the need for fiber and allowing quick expansion of 5G coverage, especially in remote or high-density areas. Explain how dynamic spectrum sharing (DSS) supports the rollout of 5G. DSS allows 4G and 5G to coexist on the same spectrum, enabling operators to deploy 5G on existing 4G bands, which accelerates 5G deployment and maximizes spectrum use. What role does 5G play in V2X, vehicle-to-everything, communication? 5G supports V2X by enabling low latency, high reliability connections between vehicles, infrastructure, and pedestrians, critical for safe autonomous and connected driving. What is the purpose of a GNB in 5G architecture? The GNB, Next Generation Node B, is the base station for 5G networks, handling radio communication with 5G user equipment (UE), and managing traffic between the device and the core network. How does 5G support mission-critical communications? 5G supports mission-critical applications with URLLC, ultra-reliable low-latency communication, providing guaranteed data rates, low latency, and high reliability needed for applications like emergency services and industrial automation. What are the main functions of the NEF, network exposure function, in 5G? The NEF provides secure exposure of network capabilities to external applications, enabling integration with third-party services for IoT, cost control, and more, essential for 5G's flexible ecosystem. How does 5G improve energy efficiency in mobile networks? 5G employs energy-saving techniques like adaptive power allocation, AI-driven load management, and efficient sleep modes for base stations, helping reduce power consumption per bit compared to 4G. Explain the concept of 5G near, new radio, and its significance. 5G near is the radio access technology for 5G, designed to support higher data rates, lower latency, and more devices compared to 4G. It's the foundation for delivering the high performance and flexibility of 5G networks. What is the XN interface in 5G, and what is its purpose? The XN interface connects neighboring GNBs, facilitating user mobility and handovers within the 5G network, ensuring seamless connectivity as users move between cells. How does 5G support AR and VR in education? 5G's low latency and high throughput enable interactive AR/VR experiences in education, such as virtual labs, immersive learning, and remote collaboration, enhancing engagement and accessibility. Describe the role of non-standalone (NSA) 5G deployment. NSA 5G leverages existing 4G infrastructure for core services, with 5G primarily enhancing data speeds. It's a cost-effective way for operators to begin 5G rollout before full standalone deployment. What are small cells in 5G, and why are they important? Small cells are low-power base stations that improve capacity and coverage in high-density areas. They're essential in 5G to provide reliable connections in urban areas, stadiums, and other crowded spaces. What is the significance of E2E, end-to-end, encryption in 5G? 0. E2E encryption in 5G ensures data security across the entire network path, protecting user data from interception and providing privacy and security for sensitive communications. Explain how 5G's massive device support benefits smart cities. 5G can support up to 1 million devices per square kilometer, enabling IoT devices like sensors, cameras, and meters in smart cities to communicate seamlessly, enhancing city management and services. How does 5G address the challenges of latency for gaming applications? 5G reduces latency through techniques like URLLC, MEC, multi-access edge computing, and optimized network routing, creating responsive and immersive experiences for online gaming and cloud gaming. What is the purpose of the N2 and N3 interfaces in 5G? N2 handles control signaling between the AMF and GNB, while N3 carries user data between the UPF and GNB, facilitating communication within the 5G core and access networks. How does 5G support multi-gigabit speeds? 5G achieves multi-gigabit speeds by using wider bandwidths, advanced modulation schemes like 256 QAM, massive MIMO, and high-frequency wave spectrum, allowing extremely high data rates. What is service continuity in 5G, and how is it maintained? Service continuity ensures uninterrupted connectivity for users as they move across network areas or different RATs. 5G uses handover procedures, multi-connectivity, and fallback mechanisms to maintain continuity. How does 5G handle mobility management? 5G's mobility management uses features like connected mode DRX, dual connectivity, and fast handovers to maintain connectivity and optimize battery life as users move between cells. What is the role of the AMF, Access and Mobility Management function, in 5G? 3, 2, 1, 0. The AMF is responsible for handling mobility, registration, and connection management. It also routes signaling between devices and network functions, facilitating efficient user mobility in 5G. Explain the significance of multi-access edge computing, MEC, in 5G. 3, 2, 1, 0. MEC brings data processing closer to the user by placing compute resources at the network edge. This reduces latency, crucial for applications like AR, VR, autonomous driving, and smart manufacturing. What are the security enhancements in 5G compared to 4G? 5G improves security with enhanced encryption, mutual authentication, security at multiple layers, and network slice isolation, protecting against attacks and ensuring secure communication. How does beamforming work in 5G, and why is it important? 3, 2, 1, 0. Beamforming directs wireless signals to specific users rather than broadcasting in all directions, improving signal strength and reducing interference. Especially important for high-band mmWave 5G. What is the function of a UPF, user plane function, in 5G core networks? 3, 2, 1, 0. UPF manages packet routing and forwarding, enabling low latency, high-speed data transfer between devices and external networks, critical for 5G's high data rate applications. Explain dual connectivity and its importance in 5G. 3, 2, 1, 0. Dual connectivity allows a device to connect simultaneously to both 4G and 5G networks, enabling smoother transitions and higher data speeds, particularly useful in NSA deployments. How does 5G support ultra-low latency for critical applications? 3, 2, 1, 0. 5G's URLLC technology ensures low latency by prioritizing real-time data transmission, supporting applications like remote surgery and automated vehicles. It minimizes delay and maximizes reliability. What is the significance of mmWave in 5G, and what challenges does it present? 3, 2, 1, 0. mmWave offers very high data rates but has limited range and struggles with obstacles. It's ideal for dense urban areas but requires solutions like small cells to overcome coverage challenges. Explain what network slicing is and how it benefits 5G. 3, 2, 1, 0. Network slicing partitions a 5G network into isolated, virtual slices optimized for different applications, providing dedicated resources and performance tailored to specific use cases like IoT or autonomous driving. How does 5G handle massive IoT deployments? 3, 2, 1, 0. 5G handles massive IoT with MMTC, Massive Machine Type Communications, which supports high device density, low power, and low data rates, ideal for sensors and smart devices in IoT. What is 5G NR's role in supporting higher spectral efficiency? 5G NEAR enhances spectral efficiency through advanced modulation, 256 QAM, and multiple access techniques, OFDMA, allowing more data to be transmitted within the same bandwidth. What are the key functions of the SMF, session management function, in 5G? SMF manages data session setup, modification, and release, handling IP address allocation, COS rules, and session continuity for seamless data services. How does 5G improve network capacity and reduce congestion? 5G uses massive MIMO, carrier aggregation, and small cells to handle more simultaneous connections and high data rates, reducing network congestion in dense areas. What is the importance of the N26 interface in 5G? The N26 interface enables seamless mobility between 4G and 5G, allowing devices to switch between networks without dropping connections, essential for NSA deployments. How does 5G address the limitations of traditional cellular architecture? 5G introduces cloud-native core, virtualization, MEC, and network slicing, which enhance flexibility, scalability, and responsiveness, making the network adaptable to various applications. What is the purpose of the GNB-CU and GNB-DU split in 5G? 1, 0. The split architecture separates the centralized unit, CU, and distributed unit, DU, of the GNB, enabling flexible deployment and efficient handling of different traffic loads across the network. How does 5G enhance public safety communications? 5G's network slicing, URLLC, and priority-based COS provide dedicated, reliable communication channels for first responders, supporting fast, real-time data exchange and situational awareness. What is Mobility Management Entity, MME, and its role in the transition to 5G? MME is a 4G core component, and while not used in pure 5G, it remains relevant in NSA deployments where 5G networks rely on 4G infrastructure for certain functionalities. How does 5G address network load balancing? 5G uses AI-driven self-optimizing networks for real-time load balancing, adjusting traffic flows and redistributing resources to prevent congestion and optimize user experience. Explain the role of AI in optimizing 5G networks. AI in 5G supports network optimization through predictive maintenance, load balancing, resource allocation, and fault management, improving network performance and reducing operational costs. How does carrier aggregation work in 5G, and why is it essential? 3, 2, 1, 0. Carrier aggregation combines multiple frequency bands to increase throughput and capacity. In 5G, it enables faster data rates and better spectrum efficiency by utilizing different bands, including wave, mid-band, and low-band. What is the role of 5G in the industrial IoT landscape? 3, 2, 1, 0. 5G's low latency, massive connectivity, and high reliability support IoT applications, enabling real-time monitoring, automated processes, and smart manufacturing. It's pivotal for mission-critical and time-sensitive industrial applications. Explain the purpose of slicing orchestration in a 5G network. 3, 2, 1, 0. Slicing orchestration manages the life cycle of network slices, automating resource allocation, monitoring, and adjusting slices based on demand, ensuring each slice meets its cost and performance requirements. What is cell-free massive MIMO, and how is it beneficial for 5G? 3, 2, 1, 0. Cell-free massive MIMO replaces traditional cell boundaries with a network of distributed antennas that serve users simultaneously, providing seamless coverage, higher capacity, and reduced interference. How does 5G handle resource allocation for mobile edge computing, MEC? 5G dynamically allocates resources close to the edge, prioritizing latency-sensitive applications. MEC-enabled devices process data locally, reducing load on central servers and network latency. What is sidelink communication in 5G, and where is it used? 3, 2, 1, 0. Sidelink communication enables direct device-to-device (D2D) connectivity without routing through a base station. It's used in V2X, vehicle-to-everything, communication, public safety, and mission-critical applications. How does 5G's control and user plane separation, CUPS, improve network performance? 3, 2, 1, 0. CUPS separates signaling, control plane, from data transfer, user plane, allowing for independent scaling and optimized data routing, enhancing network efficiency and response times. What are massive machine-type communications, MMTC, and how does 5G support it? 3, 2, 1, 0. MMTC enables connectivity for a high volume of low data, low-power IoT devices, like sensors. 5G optimizes MMTC with low-power modes, simplified signaling, and support for massive device density. Describe the impact of 5G on cloud-native network functions. 3, 2, 1, 0. 5G leverages cloud-native principles, enabling microservices-based, containerized network functions for scalability, faster deployment, and resilience. This approach supports agile, flexible network operations. What is inter-RAT handover in 5G, and why is it important? Inter-RAT, radio access technology. Handover allows seamless transition between 5G and other networks, e.g., 4G, ensuring continuous service in areas without complete 5G coverage. How does 5G enable high-precision positioning for IoT applications? 5G supports centimeter-level positioning through advanced techniques like multi-cell positioning and network-assisted GPS, benefiting applications like asset tracking and autonomous driving. What is the role of the Network Data Analytics Function, (NWDAF), in 5G? NWDAF collects and analyzes network data to provide insights, improving network optimization, fault management, and resource allocation. It uses AI, ML to predict traffic trends and optimize operations. Explain how 5G supports hybrid cloud infrastructure. 5G enables hybrid cloud by integrating private and public cloud environments, allowing operators to flexibly deploy applications, manage data sovereignty, and ensure performance at scale. What is Edge Network Function Virtualization, Edge NFV, in 5G? Edge NFV virtualizes network functions close to the user, reducing latency and enhancing performance for real-time applications by processing data at the network edge rather than in the core. How does 5G handle frequency reuse, and why is it critical? 5G achieves high-frequency reuse through small cells and beamforming, maximizing spectrum efficiency, and enabling more users per area, particularly in dense urban environments. What is the difference between RAN sharing and network slicing in 5G? RAN sharing allows operators to share physical radio access network resources, while network slicing divides the core network into virtual slices, each tailored for specific services and performance needs. Explain the concept of Open RAN and its importance in 5G. Open RAN disaggregates hardware and software, allowing interoperability among different vendors' equipment. This reduces costs and promotes innovation by enabling operators to mix and match components. What is the significance of Evolved Packet Core, EPC, in NSA 5G? EPC serves as the core network for 4G, reused in NSA 5G deployments to support the initial rollout by handling signaling and data transfer between 5G and 4G devices. How does network densification benefit 5G? Network densification involves deploying more base stations and small cells, improving capacity, reducing congestion, and enhancing performance in high-demand areas like cities. What is the role of SMF, session management function, in multi-connectivity scenarios? SMF manages sessions across multiple connections, coordinating resources, costs, and traffic flow between 5G, Wi-Fi, and other networks for seamless user experience.